Okay, 12s. 12s. What we have here is really some more revision on measures of spread. So these are things like the range, the interquartile range, and the standard deviation. Doesn't tell us what a typical score is. It tells us how spread out our scores typically are. Righto? Does it in different ways. So, review these things here. All of them should be familiar to some extent. The one thing I'm going to point out, we talk about standard deviation. There's slightly different calculation for population and sample. We're just going to treat them both as the same. Okay? We're going to treat them both the same. We're going to work with population statistics, sort of. Now, first of all here, the range is lovely, easy to work out. The range is merely the difference between the highest and the lowest. The interquartile range, what I need to do is I need to split my data first into a top half and a bottom half, ignoring anything that may be between those two halves. Then I need to separate then I need to find the middle of the top half and the middle of the bottom half of my scores and find out how far apart those centers are. The centers of the top half compared to the center of the bottom half, how far apart they are. Right, that's the interquartile range. Now, how far apart is the biggest and the smallest score here? The greatest is 6, the fewest, the smallest is 2. My range equals 4, right? It's the difference between the highest and the lowest. Nothing to do with the frequencies, okay? Now, the interquartile range, so let's have a look over here. The range, right, it's 7-leaf plot. The smallest score is 3, the largest score is 43. So the range in this case is 40. Now the interquartile range. If I add all of the frequencies up, right, that's going to tell me that I have 6, 7, 10, 15 scores. Now that means there's 7 in the top half, 7 in the bottom half. Right, 7 in the top half, 7 in the bottom half. And that other score, right, the 8th highest or the 8th lowest, if you like, it's the same score. The median, right, belongs to neither the top half nor the bottom half. Now, so the 7th score along, the 8th score along is one of these 5s, right? So our median is one of those 3 5s. The other 2 5s and the 5 6s belong in the top half. 4s and below belong in the bottom half. So the middle of that bottom half, right, there are 7 scores there, so it's the 4th one along. 1, 2, 3, 4. All right, so this is going to be our first quartile. And in the middle of this half, remember there's 2 of these, another 5, I want the 4th after that, right, fits neatly in here, that's my Q3. Okay, so the middle of the bottom half is a 3, the middle of the top half, the median of the top half, I should say, is a 6, so my interquartile range IQR, right, is how far apart those things are. How far apart are 6 and 3? There are 3 units between them. Over here, now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 scores here in this data set. So there's 6 in the top half, 6 in the bottom half. Right? There's my halfway point. So my median is between 20 and 23. Now, the middle of the bottom half then is halfway between 12 and 16, which is 14. The middle of the top half is halfway between 31 and 39. Oh, that was weird. Halfway between 31 and 39. What's halfway between 31 and 39? Is 35. 35. So can you see that what we've done there is I have split my data up into 4 groups. Right, each group has 3 scores in it. Right, and I'm interested in the distance, in a way, between the first 2 groups and the last 2 groups, right, in between those. That's what the interquartile range is, right? My 4 groups are my quartiles. The gaps in between the first of those 2 quartiles and the last 2 quartiles, that's my interquartile range, which is the difference between those 2 numbers looks like 21. Right, 21 is the interquartile range for that data set. Okay, if you have a Casio FX82AU plus 2, like this one here, you'd think that I work for Casio, but I don't. If you have one of these, you can work out the interquartile range on that. Is worth it. I wouldn't switch just for the sake of that. They are cheap at the moment, probably. Anyhow, That's the first part. Second part. Here we go. More things here. Now we have a cumulative frequency histogram, right? So this doesn't mean the frequency of 9, right? These are our assignment scores, right? Some people got 3, some people got 9. The range is, of course, 6 marks, right? There were not 40 people who got 9. There were 40 people who got 9 or fewer marks, right? The frequency of 9, in fact, is how much it rose there. So that looks to me like 2 people got 9 marks. Anyway, how many students completed the assignment? There were 40 people altogether. Okay, that's the top. What is the range? 9 minus 3 equals 6. The interquartile range. Now, we're going to split this into groups of 10. Why? Because I want 4 groups, right? There are 40 people who did it. So the first 10 people, right, the first 10 people got 3s, 4s, or perhaps 5s, right? You can see that, right, that the first 10 people got more than 4, right? That's above 4, but it didn't cross into the 6s. So I would imagine that the 10th and 11th person both got 5 marks, right? Now my median here, we can find this here, right? That means my median is somewhere in here. My median is 6, Q1 is 5, and Q3 is 7. So my interquartile range, right? So the first quarter of people, right? The lowest quarter got marks of 3, 4, or 5. The next group above that got 5s and 6s. The next group above that got 6s and 7s. And the top performing quarter of students there, the top 10 students got marks of 7, 8, or 9. Interquartile range, 7 minus 5 is 2. Righto? Cumulative frequency histograms. Pretty useful for dealing with those sorts of things. Moving along. Mean and standard deviation from a calculator. Really common HSC question and easy marks as long as you know what you're doing. You have to remember how to use your step mode. Go back and check that video if you need to. Right? Use your calculator to show this. Well, look, what am I going to... go back and watch those videos. But you punch those numbers in, find the mean, and you determine that. Right, remember that the mean x bar equals 550. That's what you're going to get. Now, it says use your calculator to show that. I can't do that for you. I need you to check that that's what happens. The same with, look, don't worry about population. We're not going to use that word when we can avoid it because we simplify matters a little bit here for the general course. The standard deviation is this. So make sure you punch that thing in. Standard deviation is 117.26. Make sure that you can work that out. Common HSC question, you get a little frequency distribution table. It says find the mean and standard deviation, 2 marks. Oh, look, they're the easiest 2 marks in the test, I reckon, as long as you know what you're doing. Okay, please make sure that you know how to do those things. Check it out. Ask me if you don't, right? I will be more than happy to show you in class how to do that. Last of these, I know the video is getting close to 10 minutes now. But man, there's a lot of examples here, and I don't really want to skip things, particularly as I won't be present in class on Friday. So, 20 echidnas, what do we got here? The mean number of tagged echidnas per sample. Per sample. So, sometimes we did 8, 11, 5, and so on. So, this is my score, this is my frequency. Need to put my calculator in stat mode. 2, 1, and I also need to make sure on my Casio that this is going to show my frequency column. Otherwise, if you're using a sharp, then you're going to use that store an M plus thing. So I go 1. Hang on, I'm going to press pause. Okay, I'm back, and this video is getting real long. But anyway, I have put that data into my calculator now. Right, scores and frequencies. There are 6 rows of data. The mean number, remember, once you've put all your data in, you need to press clear. Right, looks like it's all gone, it's not, it's saved. That's what step mode does. Now we want the mean. So on a sharp, you're going to press alpha 4, and on a Casio, you press shift 1, and then probably 4, whatever it is for VAR, and then probably 2 with the X bar above it. The menu's changed a little bit according to the model of the calculator, and equals and 1.4. Am I happy with that answer? Yes, that looks about right. Okay, while there were sometimes 5 echidnas sampled, really, most of the samples were either 0 or 1. So that looks okay to me, 1.48. 2 decimal places, that's right, 1.48. Now, don't worry about sample there. Standard deviation, again, on the sharp, right, on the sharp, it looks something like this. Right, so you want your standard deviation, it should be alpha 6, and then equals. Right, on the Casio, shift 1 for stats, probably 4 for VAR, and then 3 for standard deviation equals, and I reckon 1.34. 1.34. We'll talk a bit more about standard deviation in class and what it means, but in fact that belongs more in our next topic altogether, right? Not just in the next exercise. Okay, hopefully you haven't fallen asleep during this video. It's a particularly long one, so I'm going to stop it there. But write down, fill out these things, practice on your calculator, make sure you can do it, write down questions. Somebody is going to need help in class. Make sure that you ask those questions, please. Thanks.